last topic from the last chapter, okay? So you have already covered the topic about the moon, and I actually forgot to teach you about this. So what do you see here? Solar system. Planet. Yes, solar planet. And what is at the center of the solar system? Sun. Okay, sun. And what is revolving or rotating around the sun? And what do you call the path of this planet? Orbit. Now, keeping this structure in mind, what can you see here now?
Atom.
What is this structure about?
Atom.
And what is at the center? What is that red ball?
Nucleus.
Okay. And what is that two balls that is rotating? Electrons. So comparing our solar system and the structure of the atom, the sun represents the nucleus. Okay. And the planets are the electrons. And the path is also called as the, even in atomic structure, the path of an electron is called as orbit, or in later years you will learn it is orbitals, okay? But for now, just know that it is orbit only, okay? So you can see the relation in our universe, right? Even the massive structure like the solar system and the smallest thing like the atom, the both of their structures are the same, right? So in today's class, we will learn more into what is called as the nuclear atom, okay? And we will learn about the structures of nuclear atom. You have already learned this in chemistry, I think, yes?
Yes.
So now we will look from the physics point of view, okay? Nothing is different, just that the topic is there in physics, okay? So we will look at the nuclear composition, then we will look at protons and neutrons, then we will look at what is proton number and nucleon number, and then we will learn how to write a nuclide notation, okay? I will show you what is that later on. Now first of all, let me show you one quick demonstration. One second. Okay, have you seen this before? No? So can you choose any element from periodic table 1 to 10? Or can you name the element?
Nitrogen. Sodium.
From 1 to 10.
Nitrogen.
Nitrogen? You want to do nitrogen?
Nitrogen.
Okay, let's do nitrogen. So what is the atomic number of nitrogen? 7. So when we say 7, what thing do we know? How much proton do we need?
7.
So I have to, but I will keep here. I don't know why it's not. 1 second, okay. So now, first of all, I will add protons. What can you see? What did it become? Hydrogen. So you said nitrogen, let's add 7. 1, 2, 3, 4, 5, 6, 7. And I can add neutron also. Now what you can see is, this nitrogen is only a ion right now. I want to build an atom. So what do I need to add? How many electrons should I add?
7.
What happens if I add less than 7? So the nitrogen still becomes a ion. If I add more than 7, it's still an ion, right? Okay, so let us see. I'm adding the electrons. Okay, 1, 2. Can I add one more electron here?
No.
Why?
Limitations.
Limitations, right? First shell only accepts true. So even in this simulation, even if I try to add here, it will automatically go here. Okay, see? So 1. How many do I need?
7.
5.
5 more, right? No. I think 3 and 4, 5. It is still an ion. 6 and then 7. So after adding 7 electrons only, this nitrogen became a neutral atom, right? Now can you define what an atom is? After showing this, after knowing about this structure, how would you define an atom? Or what can you say an atom consists of? There's a difference between atom and ion, okay? Now any volunteer, if you like to define what an atom is, or you can say what an atom is made up of. Yes?
Atom is made up of protons, neutrons, and electrons.
Protons, neutrons, and electrons. Okay, thank you. So an atom is made up of protons, neutrons, and electrons. Okay, this is how we write in the short form. P for proton, N for neutron, and E for electrons. Okay, and I think you know so much about all these three things. Let me show you the slides. Okay, so first thing, like I said in the diagram, you need to know about atomic orbitals. Okay, so orbitals are the. Can you see? Can you read from the last page? Are you able to read?
Yes, sir.
Can you read? Everyone?
Three-dimensional regions where electrons are most likely to be found in an atom.
So atomic orbital, it is the region where an electron is found, okay? Or it is the path where the electron is revolving or rotating around the nucleus, okay? And the second thing you need to know is about this electron. What do you know about electron? They are negatively charged, okay? This is how we write negatively charged, okay? And what do you know about proton? What kind of charge does proton have?
Positive charge.
So if you want, how do you want to remember? P for proton and P for positive, okay? So P is positively charged. And what about neutron? Neutron. N for neutron, N for neutron, okay? So that's how you remember neutron. Now we have talked about nucleus also. So what can you know about, what do you know about nucleus? Atom consists of protons, neutrons, and electrons. So nucleus consists of yes, protons and neutrons. Protons and neutrons. So these protons and neutrons all added together, it forms one ball, okay? And that ball is called as the nucleus. It is a kind of misconception that protons and neutrons is inside the nucleus. It's not like that, okay? You must have seen something here and like this. It's not like that, okay? Protons and neutrons are clubbed together in a densely formed manner, and all these protons and neutrons, they combine together to form one ball, and that ball is called as the nucleus, okay? So nucleus is the combination of protons and neutrons. Atom is a combination of protons, neutrons, and electrons. One extra electron is there, okay? Alright. So like I said, neutron, which is neutral, atomic nucleus, positively charged center of atom containing protons and neutrons, and then protons, which is positively charged particle in an atomic nucleus, okay? Any questions so far? Clear, right? Okay. Now we will apply to notation. Have you heard of this word before?
No, sir.
Can you guess? Yeah, understood. Understood. Okay. Can you guess what a nuclide notation might be? Just focus on the word notation. You have learned about scientific notation, right?
Yes, sir.
So can you guess what do you mean by nuclide notation? Just what do you mean by notation? Don't worry about the word nuclide. Notation might be just a hint. So we write like this. We have X, we have Z, and we have A. This is nuclide notation. Now, what do you know about nuclide notation? What might be nuclide notation? Any guesses? No, it's okay. You can say anything you like. Your answer don't have to be correct. Say this.
Short form representation
Short form representation of
of an
an atom or an, what do you call those things in the periodic table?
element.
Elements. Okay, good answer. Thank you. So nuclide notation is nothing but it is a short way of representing an element in a periodic table. Okay. So in this case, this is how we represent a nuclide notation. We write X, Z at the bottom, and A at the top. Okay. And X is what? What do you think X might be?
Element.
And to be more precise, X is the symbol of the element. Okay. So X is the symbol, Z is the atomic number. Okay. We write atomic number at the bottom. So Z is the atomic number. Atomic number is also called as. There is another name for atomic number. Yes? No, it is correct. I heard it. And if you flip that what number of protons? Proton number. Okay, atomic number or a proton number. And this E is called as the
Mass.
number. So mass number also has a different name. Can you guess? Might be a new word for you. In the objective I showed you actually. When I said today we are going to learn something, so many things, right? And I have showed you that mass number is also called as. What do you mean by mass number?
Total number.
Total number of
Total number of neutron and proton.
total number of neutron and proton. And I said neutron and proton combines together to form nucleus, right? Now
Nucleus
can you guess-
number.
It's slightly different. It is
Nuclear number.
if nucleus is plural, what is the singular form of nucleus?
Nuclide.
Yes? Slightly close.
Nucleo.
90% correct.
Nucleo.
Nucleon, okay? So it is called as the nucleon number. So just a different name only, okay? Don't get confused. So if I ask you what is the nucleon number, I'm asking you the mass number, okay? And if I ask you proton number, it is the atomic number, okay? It's just synonyms, okay? So don't get confused. Just know that mass number and nucleon number are same, and atomic number and proton number are same, okay? So this is how we represent. Now can you again give me any element from 1 to 10?
10.
Fluorine.
Neon.
So what is the atomic number of fluorine?
9.
Okay. And where do you write 9? Here. And what might be the mass number of fluorine? Can you check your periodic table if you have in their factor book? It might be in a decimal place, so can you tell me the number? Fluorine, in top of fluorine, what number do you see? 17, okay. So I will write 17. Okay, so from this figure, let me write it properly. Can everyone see?
Yes,
Can I write
sir.
here? Okay. Fluorine, 9, 17. Okay, and if I ask you what is the proton number? 9. What is the nucleon number?
17.
What is the number of neutrons?
9. 8.
Why 8?
17 minus 9.
So 17 minus 9 will give you the 8. 8 is the number. So what is that number?
Neutron.
Number of neutrons. Okay. So are you clear? So neutrons plus protons will give you mass number. Okay. So if I say the atomic number of an element X is 5 and the number of neutron is 6. What is the mass number? 11. Okay, so that's how we calculate. Very simple, right?
Yes, sir.
So protons plus neutrons will give you mass number. This is the only formula that you need to know, and atomic number is the proton number. Okay. And what can you tell me about the significance of proton number? If you know the proton number of something, what do you know about that? Let's say if I say like the proton number of element X is 7. What do you know about the element?
We know it is nitrogen.
We know that it is nitrogen. So what is the significance of proton number?
We can identify the element.
The proton number tells us the particular element, or it helps us to identify which element it is, right? And what is the significance of mass number? So like I said, proton number is all same thing, okay, whatever I showed you. It's the number of protons in the nucleus, and it determines the identity of the element. Just like you all have your own roll numbers, right? If I say roll number 10, only one person will stand up, right? So just like that, atomic numbers are like the roll numbers for the elements, okay? That's how we remember. And nuclear number, it is also known as the mass number, and like I said, it is the number of protons and neutrons, right? And it gives us the mass of an element. See, can you see the last sentence?
Yes,
The significance of nuclear number is that it gives us the approximate mass of the atom. So it says mass of the atom is only about protons and neutrons, right? Why are we not including electrons in the mass number? When you say the mass of an atom, we only consider protons and neutrons. Why are we ignoring electrons? Is electron of different caste that you are ignoring them? Can you just guess? You don't have to know, just you might know. Try to guess. Protons and neutrons is only the thing that we consider while considering the mass number of atoms, right? So do you think, why do you think we are not including electrons?
Electrons are present in the shell.
But it is inside the atom only, right? I said atom consists of protons, neutrons and electrons, right? But when we say mass of an atom, we are not including electrons.
They are not present in the nucleus.
But we can say just nucleus number, nucleus mass of nucleus, we are saying mass of an atom. Can you think, anyone like to try? Might be a different, think outside the box. No, actually, because everyone is thinking outside the box, the inside of the box is the new outside of the box, okay? So think inside the box. Focus on the word mass. The hint is nothing about the charge, focus on the word mass. In most physics calculations, we say ignore friction, ignore air resistance, right? Not quite. Half is correct. Half of the answer is correct. Very close. You think they have mass, but we do something. We do something on that mass. We are not including. So what we are doing with that mass? We are ignoring, right? So we ignore the mass number. That's the reason. Okay. And do you know why it is? Because the mass of an electron is around 2000 times less than proton and neutron. Okay. So while comparing the mass of electrons with that of proton and neutron, it is very, very less, okay? So we are neglecting or ignoring the mass of an electron. That is the simple reason, okay? So mass number is just proton and neutron, okay? Clear? Yes. Any question? No. And one thing you have to know as per the syllabus is the radioactive elements, okay? What do you mean by radioactive? A radio that is active. To you about radioactivity, you know, there is one movie also where the main character is Madame Marie Curie, and that movie name is Radioactivity. Now, can you guess what you mean by radioactive?
Radiation.
Radiation. Now, what do you mean by radioactive elements?
Radiation.
Elements that
Have radiation.
that what? It is producing or emitting radiation. Okay. So elements that emit radiation is called as radioactive elements. And do you know what a radiation is? You have learned in chapter 3. Conduction, convection, and radiation. So radiation is a form of heat, and heat is a form of
Radiation.
heat is a form of you can't see. Do you see heat? But you can see gas, no? So heat is a form of energy. So radiation is also a form of energy. So you can see radioactive elements are those elements that have unstable nucleus, okay? Their nucleus is unstable, and because it is unstable, they will break down and it will release energy in the form of radiation. And radiation can be in the form of alpha, beta, or gamma rays, okay? These are just the name of the rays. You don't have to know right now. There are different rays, so radiation will be released in the form of alpha, beta, or gamma rays, okay? Now we will have an activity. I will give you one radioactive element in each group. You will have to write the nuclide notation, okay? Does everyone have a periodic table, at least one in each group? Yes. Okay. So this is the group number, okay? 1, 2, 3, 4, 5, 6. And these are the radioactive elements. So you are doing uranium-238. Radon 222, plutonium 239, thorium 232, carbon 14, and iodine 121. Okay? And before you begin, everyone look here. Do you know what are these numbers 238, 222?
Yes.
Mass are the
Mass.
and the uranium radons are the A elements. So I have already given you X and A. All I want you to do is find Z and calculate the number of neutrons, okay? So your task is to write the nuclide notation, write it properly and calculate the number of neutrons, okay? I'll just give you 2 minutes because you just have to write, okay? You don't even have to think anything. Just find the set of all these elements from the periodic table and write in this form. Write it big so that everyone can see, okay? I want you to stand up and show it to the class. So let us begin from group number 1. Let's see if your answer matches my answer, okay? So anyone, can you show it to the class? Can you please stand up and show it to the class? So there was uranium-238, okay? What was the proton number? Oh, you should know without looking by now. 92, okay? And what was the neutron number? 136. We will just cross check that group. Please, thank you. Second group, can you show it? Okay, theirs is radon 222. Can you show it to the class now? Okay, so can you tell me the proton number? Proton number 86 and neutron number was? 1. Neutron is the addition of proton. No, the neutron number, you subtract mass number from proton number, that's how you get this. Okay? Thank you. So group number 3, there was plutonium 239, and are you able to see? No. Can you read the proton number? What is the proton number? What is the proton number? 94. 94, and the number of neutron is 145. Okay, group number 4, there was thorium, and the proton number is
90.
and the neutron number is
232.
We have discussed property. We have literally written there. Can you read?
142, sir.
142. Okay, group number 5, carbon 14, very easy, right? Very familiar with carbon. So carbon 14 is also radioactive. Okay? So how much is the proton number? I mean, the proton number? 6. And the neutron? 8. Okay. Thank you. And last group, iodine 131, the proton number was? 53. Okay. And the neutron number is 78. All the way. So let us cross check the numbers. So 92 146, 86 136, 94 145, 90 142, 68 and 53 78. Okay, everyone was correct. Please clap for yourself. So you see, right? Don't get confused. Okay, some are still getting confused as in what is the neutron number? Neutron number, we subtract the mass number with the proton number. Okay. So like I said, Z plus N will give you A, okay? That is the equation. Clear?
Yes, sir.
Alright. So we have 5 minutes, so let us do one short quiz. I will ask quiz from one question to each group. If you are not able to answer, it will be passed on to the next group, okay? So the same group, 1, 2, 3, 4, 5, 6, and let's how you will answer. Okay. So find the element, and these are the numbers. I'm asking to this group. You give your answers to yourself. The Fluorine. Fluorine. And the second part of the question is it neutral or ion? Why neutral? Why ion? How do you know something is neutral? It has equal number of protons and electrons. Okay. So that becomes the neutral. Okay. Alright, 2 points. Thank you. Now, second group, this is your question. Just this structure. I think this is neutron and this is proton. Hydrogen. Okay. Is it neutral or ion? Ion.